Okay, this is a matrices again. Matrices. Mostly in this lesson, we're going to learn about inverse matrices and using inverse matrices to solve problems. So inverse matrices. And this video is for homework 52B or enrichment activity 52B, learning about matrices. Okay. So what we want to do in this one, the first thing is I need to teach you something before we talk about inverses. Okay, it's called capital I. Okay, now capital I is called the identity matrix. Identity matrix. And specifically, it's going to act, I spelled matrix wrong. It's going to act, identity matrix. It's going to act like the number 1. Okay. So how does 1 act? What's a number? 5 times 1. What do you get back? You get back 5 again, right? Okay, that's called the multiplicative identity is the official name for that. Okay, so if I'm doing a 2 by 2 matrix, it turns out that the identity is 1s along the diagonal. You'll recognize this from augmented matrices. 1s along the diagonal and 0s everywhere else. It's very cool. If you multiply this matrix by any matrix that is legal to multiply it by, you will get back the original matrix. Now, you can also have another identity matrix. Okay, if you have a 3 by 3, 1s along the diagonal, 0s above and below your 1s. That's called the identity matrix. Okay, and it's just a capital I. What if it were 4 by 4? Now we won't be doing 4 by 4s by hand, but we can do a 4 by 4 or higher on the graphing calculator. So we're going to put the 0s in above and below the 1s, and the 1s are across the diagonal. So the 1s are across the diagonal. Okay, so that's called the identity matrix. And the property of an identity matrix property of identity matrix is if you take a matrix and you multiply it by the identity, you get the original matrix back. If you take the identity and you multiply it by the matrix, you get A. So that is the identity matrix. Now, the reason why we need the identity matrix and the inverse matrices is because there's no such thing as division in matrices. Division by a matrix, so we have to have a different way to be able to act when we want to be able to divide. Okay, so let's talk about an inverse matrix. Okay, so there's going to be a formula, and we can make the formula using augmented matrices. Okay, so an inverse matrix. We're going to have a 2 by 2. So this is A, B, C, D. Okay. And A inverse. Inverse is used like sine inverse, cosine inverse. I just got an email from AP, so that's interesting, but I'll wait on that. Okay, so what it is it's 1 over the determinant in the front. So I'm going to put DET A. So 1 over the determinant goes in the front. And then what you do is the down diagonal, you switch the order. So you put D here and A here. So you switch the down diagonal. And for the up diagonal, okay, the up diagonal, you change the signs. So it's negative B and negative C. And if you multiply these, you end up getting the identity matrix. So somebody figured it out for us, and we're just practicing using it. Now, the 3 by 3 inverse matrix is something that we don't have to do. If we did it, we would use augmented matrices, and then we might as well just use augmented matrices to solve the problem. So an inverse matrix, this is the formula. So this is the formula for a 2 by 2. If they actually ask you for the matrix, I would suggest distributing. But at the moment, we don't distribute when we write it down. Okay, so let me show you. Say it says find the inverse. Okay, actually, we'll do find the inverse first. And then I'll tell you what the homework questions look like. So A is 2796. And they say find A inverse. Okay, so this is example 1. Find A inverse. So what you do is you say, okay, well, I have my formula. So what's my formula? So my formula, and usually this is not a formula people write down. They more just do it. Okay, so the down diagonal, you switch the numbers. So you put 6 and then 2 instead. And for the other diagonal, the blue diagonal, okay, you're not multiplying them. Your blue diagonal, you're changing the signs. So -7 and -9. And then you do need the determinant. So let me find the determinant of A over here. So determinant is the down diagonal multiplied minus the up diagonal multiplied. So that's 63. So this would be -51. Okay, is that determinant? And then you can show the work if you want. 2 times 6 minus 7 times 9. Okay, and then you put 1 over that number in the front. Now, if it was a question that said, what is A inverse, I would distribute. Okay, so that would be -6 over 51, +7 over 51, +9 over 51, and -2 over 51. Now, if it said use the inverse, I don't think I would distribute it because I'd rather not deal with the fractions. I'd rather deal with the number in the front. So if it just said what's A inverse and that's your only job, I would distribute it through, except that's not reduced. So I shouldn't box that. 51 is not prime. So that's -2 over 17. No commas in matrices. My puppy is so noisy today. 7 over 51, 3 over 17, and -2 over 51. Hey, beautiful. Hey. Hey. Who's out there? I guess it's a beautiful day and people are walking. So she's just barking at the people outside. So this would be the answer to the inverse. Okay, now there's a question in the homework. So let me just put homework. Okay, and right now, because we're in closure, homeworks are optional, but you do want to learn the material. So we won't be able to catch up on all the material when we get back. So this would be a chapter that you just don't learn. And then when you need it in the future, you won't have learned it. So I would suggest trying to learn it now if you have time. If you don't have time, you can learn it in the summer. You definitely will need it in the future math classes. You don't need it specifically for calculus. So we pick topics that you wouldn't need for calculus, but that doesn't mean that you don't need it. Okay, so we pick those topics so that it would help you in case you and your family were in a situation where you couldn't do the work until April 20th. Okay, so on the homework specifically, there's some questions that say show B is the inverse of A. Oh, we have a delivery. So they're barking at the delivery man. Okay. 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 So show B is the inverse of A. Okay, so the way inverses work, like the definition of an inverse, is that if you multiply A times the inverse, you should get, now think of if you were doing inverses of multiplication inverses. Inverses is like the reciprocal. So it would be 5 times 1/5, which would be 1. So the way the identity works is when you multiply two matrices, you're supposed to get the identity if it is the inverse. It's like one undoes the other. And this is actually a multiplicative identity. There's also an additive identity, but we don't talk about that too much in math because it's not, it's division that's the problem, not subtraction. So show B is the inverse of A. So these are your two facts right here. Oops, not erase that. These are your two facts. Okay, so if I want to show B is the inverse of A, I do B times A, and I do A times B. You do have to do both of them because you don't get the same answer. And they're supposed to turn out to be the identity matrix. So what they want you to do is they want you to practice that matrix multiplication from the previous chapter. And then it's going to turn out to be one of the identities. 1, 0, 0, 1, or maybe probably won't have one that's bigger than 3. Okay? And then that's what you're supposed to get. So in the homework, I'm not going to show an example of that, but basically it just wants you to multiply it and then show that truly it is the identity matrix. Okay, the delivery guy left, so I can come back into my normal spot. I think I need to change my spots with these puppies during the day. Okay, so that one says show that B is the inverse of A. So you have a few questions that are going to be like that. And that's number 7 and 8. And then 13 through 20 say find the inverse. So you're going to find the inverse or say the inverse doesn't exist. So that's interesting. So if you have one of these matrices, if you look at example 1, or if you look at the formula, how could it not exist? It's very interesting. So how could it not exist? So the way it does not exist is if the determinant is which number. Which number would give you a problem? 1 over which number? So it's if the determinant is 0. Now I do notice that 19 and 20 are 3 by 3 determinants on this page. I would say don't worry about doing those at the moment because really the way that you do it is by an augmented matrix. So I would say 19 and 20 is not very important. Okay, so don't worry about 19 and 20. If you want to know how to do it, basically what you do, okay, so let me just basically show you, because there is no formula. Does it say find the inverse? Oh, maybe we should do those on the calculator. So let's make 19 and 20. Let's make 19 and 20 graphing calculator problems, okay, which is find the inverse of a 3 by 3. And that's going to be another video, which is just find the inverse. But if you wanted to do it by hand, how you find the inverse of a 3 by 3 is you do an augmented matrix that's like this, okay, and you put your A, B, C, D, E, F, G, H, I here, and you put your identity matrix over here, okay, but you really won't have to know how to do this unless sometime in college they show you, and then if they do show you and they wanted you to do it, then they would just show you then, but it would not be too big of a deal. But what you have to do is you have to use all those steps. Remember those steps for augmented matrices? So you're going to use all your steps for augmented matrices to change these into 1, 1, 0. Well, you know, you do your 1 and then you get your 2 zeros and then you get your 1 in the middle and your 0 on the top and the bottom and your 1 at the bottom and then your zeros here. And then whatever your answer is over here is the inverse of a 3 by 3. So there's no formula. It's the RF process. Okay, the RF process. The RF process is Gaussian Jordan elimination. Okay. So that's not the plan. Let's have you do those on the graphing calculator instead. And not with you're not going to do it. This is, we'll put this as by hand. Okay, so you're not going to do it with Gaussian Jordan elimination. You're not going to use it with RF on the calculator. There's a button called inverse. Okay, and you're going to be able to just find the inverse directly with a calculator. Okay. So this will be on the calculator part of your test. Well, it is on the calculator part of the test. I'm not sure how we're going to be doing tests. We did learn today that you will be learning come April 20th, but we haven't figured out how we're going to do tests yet. Okay, so that's 19 and 20 on that page. And then let's see, 23 to 25. That one is saying use a graphing calculator to find those. And so definitely those you're going to use a calculator on. And then 20, that's through 30. Those are all 25 through 30. And 19 and 20. 19 and 20 are also graphing calculator ones. You know, I'm going to put that right here, and then I can post that. Those are graphing calculator. This is 18, 19, 20. I'm going to put a GC on that one, and I'll post that in the main class. So anything GC you can do with your graphing calculator. Okay, and then I didn't see any other graphing calculator ones so far. Okay, and then 35 through 44 on this page, it says use the formula to find the inverse. Okay, so you're going to just use the formula to find the inverse. Now, 41 through 44 are going to be a little bit tricky. And I think I'm going to have to stop with just inverses. And then the other page, I think I'll show you in another video. Let me see what the other page is. Okay, well, you'll be able to practice those. You don't even need a video for that. 25 through 28. Okay, those are going to be calculator ones too. Let me put this, graphing calculator. I'm going to put these on yours. I'm looking at the assignment sheet right now. Okay, and then 67 through 73. Does it say use a calculator? It does not say that on those. Okay, but you already know how to do those. So actually, you already know how to do most of this whole homework. Okay, so once I teach you this part. So this part's a little tricky. Okay, this part's a little tricky. We used to use this a lot more before we learned augmented matrices. Okay, so before I taught my students augmented matrices, this is example 2, I had to use this method a lot. Now, the disadvantage of this method is if you get one of those weird answers like z equals t and x equals and those parametric things, the inverse doesn't work. So the inverse method does not always work, but it is a method that you have to practice and get good at so that you know another method. So let's see. So let me show you the process. I'm thinking I should show you the graphing calculator, not the actual graphing calculator part, but how I do it with the graphing calculator first. I think I'll show you on the side. Okay, so let me show you how the questions look. 2x plus 3y. Let's see if I can pick one that isn't terribly. I'll pick this one. Oh yeah, those are terrible numbers. Okay, let me not pick that one. Okay, so let me pick 2x minus 3y equals 7 and 5x plus 4y equals 10. Let's see, is this going to give me some nasty stuff? Let's make that a plus. That'll come out nicer. Okay, so we're going to make them both pluses. Okay, now we're doing it with a 2 by 2. Yes, we would use elimination, but what if it's a 4 by 4? What if it's a 6 by 6? What would our plan be? So we're learning it with the smaller amount of letters, but really it's used more for more letters. Okay, and then technology, using technology on it as well. But we want to really see how it works. So what you're going to do now, this is called write. So the instructions on the test would say solve using inverses. And then it says show all steps. Okay. Okay, so the first thing you're going to do is write as a matrix equation. So write as a matrix equation. That means that you have an equation with only matrices. So I'm going to show you what it looks like and then convince you that it makes sense. Okay, those are too tall, so 2 rows. And the first one is 2 columns, second one is 1 column, last one is 1 column. So this one is 7, 10, the coefficients. The second column is actually x, y, and I'll show you why that works in just a minute. And then this one is the coefficients of the x and the y. So this is different than an augmented matrix. Okay, this is solved using inverses. Now I'm going to write on the side the calculator work. Okay, because the calculator work really helps you to understand. Now we're not doing this. This is by hand. Okay, so we're doing it by hand. But the calculator work kind of helps you organize your thoughts as you're going through this. So let me show you what it looks like. It's A times capital X equals B. So that's the original matrix equation. So what my plan would usually be is to get X by itself, it would be to divide by A. But there's no such thing as division with matrices. So how am I going to do this if I'm not allowed to divide? Well, imagine you had 5x equals 3. What if the divided by button on your calculator wouldn't work? What's your other choice? Your other choice is you could multiply by 1/5. Now 1/5, the word reciprocal, is also called the multiplicative inverse. Okay, multiplicative inverse. And so it's the inverse of multiplying, basically. And what we're going to do is we're going to do the same thing as that, but we're going to do it with A, X, and B. Now we have a slight problem. It's not a big problem, but our problem is when you multiply by the inverse, okay, and I'm going to write that as a new step. When you multiply by the inverse, let me do it in another color. I'm going to rewrite this step so that you can see it. Okay, when you multiply by the inverse, I just did what I call left multiplying. That is left multiplying. Now, since matrices matter what order you multiply, you can't multiply A inverse on the right. Okay, that's a no. Okay, you cannot multiply A inverse on the right. So this is illegal. You have to put it on the same side as the one that you did on the other. So you have to left multiply by A inverse on both of them. Okay, so you have to left multiply. Okay, now what did we say A inverse times A is equal to? So if you scroll up a few, it tells us that A inverse times A is like 1, but it's called I. X equals A inverse B times. Now, what did we say the I stood for? Okay, the I stood for the identity. So it's acting like 1. So what's 1 times X? X. So this would be the answer if you're doing the calculator. And then you'd write the answer to the calculator problem, basically. This is if you were doing the calculator way. Okay, but we're not doing the calculator way. We're going to do it by hand, but our plan is the same. So I have to left multiply in the next step. I have to left multiply by the inverse. But to do that, I need to find the inverse. So I'm going to write the inverse up here so it's not in the middle of my mess. So I need the inverse of this. Now you're allowed to write for formatting purposes. If you don't want to call it A, you can just put a little inverse right there. Okay, and remember that's 1 over the determinant. Determinant is yellow minus blue, right? It's the down minus the up. Now, what do we do with the yellow to find an inverse? We switch them, so 4 and 2. And what do we do with the blues, the up diagonal? You change the sign. Okay, now normally I would want to multiply that, but that's going to be a huge mess. So I'm going to leave the 1/7 in the front. Now hold on. I'm going to rewrite this one so that you can really see the steps. Okay, but I do need space to left multiply by that inverse. Okay, so I'm going to use a different color so you can see it. I definitely suggest you using a different color in this problem, the red. So negative 1/7 times 4, negative 3, negative 5, 2, and negative 1/7, 4, negative 3, negative 5, 2. So you have to left multiply both of them. Okay, now usually when I do this, now they did say show all steps, so they don't want you just to assume that this answer is I. They want you actually to work it out. Okay, so what you're going to do is you're going to multiply your row, yellow row, times your blue column. Okay, and you're going to write that somewhere. So that's what? 8 minus 15. So negative 7. This is just my work up here. So that's negative 7. Oh, and let's check. 2 by 2 and a 2 by 2. The middles match. Your answer is a 2 by 2. So at the moment, my negative 1/7 is still sitting out in the front. So is this, and I'm going to procrastinate the right. So that is multiply the first in the yellow and the first in the blue, which is 8. Oh, sorry, we got what, negative 7? So 8 plus negative 15 is negative 7. So negative 7 is going to go right here. Then you're going to do the blue times, or the yellow times the skinny blue. So up here, I'm going to write that's what, 12 minus 12, which is 0. Okay. And then I'm going to multiply my skinny yellow by my thick blue, which would be, and that 2 looks funny to me because it has a line under the 2. So let me erase that line. Okay, so skinny yellow times the thick blue would be negative 10 plus 10, which is 0. I'm feeling good because remember, I'm going to distribute that in the next step. So I feel like I'm on my way to 1001. Okay, and then skinny blue, skinny yellow, skinny blue would be what? Negative 15 plus 8, which is negative 7. So now if I distribute this, do I get my I that I wanted to get? I do. So basically, the reason why you're learning this is the process. Okay, you're learning the process and you're seeing that it really does work. Okay, at least with our examples. I'm going to keep going on the left side. This is now matrix multiplication. I need to multiply the 1, 0 times the column. Oh, let's check the sizes. This is 2 by 2. This is 2 by 1. You are allowed to multiply them, and you're going to get a 2 by 1. So 1 times x is 1x plus 0 times y. That's x. So that's going to go here at the top. And then 0 times my skinny yellow. Oops, that was in the yellow. Okay, wait, I lost my line. Okay, so my skinny yellow times my blue would be 0 times x plus 1 times y, which is y. Okay, so now that I know I really have what I wanted to have, I'm going to work out the right. So yellow times blue, which you should pause so that you can work these out. Okay, so I'm going to write over to the side, that's 28 minus 30, negative 2. And then I multiply my skinny yellow times my blue, which would be negative 35 plus 20. And that's negative 15. Now, if you haven't done any of the practice questions, that matrix multiplication is going to go way over your head. So you want to make sure that you're practicing and not just watching the videos. 2/7 and 15/7 if I distribute. 2/7, 15/7. And then the final answer is x equals 2/7 and y equals 15/7, which you would write as a coordinate. Now, because of the other day where I made an error, and then you guys found it later and you let me know, which is totally awesome. I love when you guys find my errors. 2x plus 3y equals 7 and 5x plus 4y equals 10. I'm going to check that the answers work. I do not require that you do this. Of course, if you finish a test early, you might want to do it. That's what, 4/7 plus 45/7. Oh, seriously? Oh, that does work. Okay, that's fine. 49/7, which is 7. Okay, it's probably right. But technically, I should try it in both. So that would be what? 10/7 plus 60/7, which is 70/7, which is 7. 10. 10, which is 10. Okay, so it works. So both of them work. So that answer is the correct answer. Is there an easier way to do it? Oh my gosh, of course. Please, elimination. But we're practicing inverses. So we really don't want to practice on a 3 by 3. So we want to practice on a 2 by 2. Now we'll do a graphing calculator one on like a 5x5, but definitely, I do not want to practice by hand a 3x3 because that's going to be way too much multiplication. So you got to practice this. There's 4 of them, I believe, in the homework, and you want to practice them to get really good at this. Don't skip any steps. The whole point is the steps, okay? If the point wasn't the steps, we would use elimination, okay? We would use another method. Okay, this part right here at the bottom, definitely you don't need. I'm going to put it in a bubble. Okay, that was just me checking my answer. You don't need this. I usually write that on there, though. I do want to go back up here to discuss with you why the matrix equation is legitimate. So look at the matrix equation, 2, 3, multiplied by xy. Oops, that's usually, I've been making that blue, haven't I? Oh, no, I don't want my face. Okay, so hold on, let me move that away. Back arrow. Okay, so I'm looking at the right as a matrix equation. Okay, so look at the yellow I just highlighted and the xy. Well, if you multiply those, the 2 would go with the x and the 3 would go with the y, and you would add them. So that's 2x plus 3y, and that's why that equals the 7. And then in your bottom row, that would be 5, 4 times xy, which is 5x plus 4y, and that is supposed to equal 10. So that's what allows you to do this process. Okay. So that's solving using inverses. And then we will also do that with the calculator. There is a calculator part of this test. So if you were taking tests, which like I said, we have no idea exactly what we're doing, but if you were taking tests like they have always in the past, there is a question like this. There's also a calculator part of the test. So you want to be able to do this with the calculator and then without the calculator. Okay, so let's see what's next. So that would be for 41 through 44 on the homework. And then that is, we already talked about that. You know how to do all those, except this is on the other page. Okay, so you know how to do that. 79, page 579, 63 through 73. You know how to do all that. Remember what the absolute value bars mean. Okay, the absolute value bars, think of what they mean. Okay, and remember they mean the determinant. Okay, and then I'm going to check out the next page just to see if you're okay for this homework. I'm looking at 52B. What a long homework assignment that must have been, since 52A and 52B used to be the same homework assignment. Okay, and then what does this one say? This one is 51. Oh, these are graphing calculator questions. Oh, excellent. Okay, so these are also graphing calculator questions. I'm going to put GC and then post this one separately on the homework. And then 80, this is also using graphing calculator. Okay, so the rest of the assignment is using a graphing calculator. So I'm going to make a video of just graphing calculator. Okay, so this is exciting. So I'm going to post this one. This is homework 52B. So right now you're just waiting on all the graphing calculator questions. Okay, and then I'll have you do the graphing calculator questions. I'll make a separate video in just a few minutes.